Hello my friend, and welcome back to another video here with me. So today I'm gonna do a slight in-betweener here, and I'm gonna explain how easy it is to understand orbits and stabilizers when thinking in terms of functional programming, just using the math function. I'm gonna explain it really simple for you, so you don't have to, like I did, think so much, what the fuck is this, you know? And I got this tip from my friend, and it was absolutely amazing, and it really got me to understand it much more easily. So I'm gonna show you, this is a question I have here from an exam, and it is in Swedish, but you know it's math, and I will translate it for you so you will understand what it means. So we're just gonna read it so we have a common question to think about, okay? So it says here, it's the sixth question if you want to practice your Swedish skills. So we have the group of permutations G and U15, and it is the invertible elements in the ring Z15, and it's supposed to function on X in Z15, and we're going to use multiplication. And it says, find the orbit and the stabilizer for both 3 and 5 in X. Okay. So first of all, we have to find the group of permutations, right? We're working in U15, so you will have to find those. I've already fetched them here. It's these numbers here, as you can see. Let's make this bigger. Can we do that? I don't know how you do that, actually. Oh, like, oh, shit, that was cool. Okay, cool. So you see here, I've found them already. If you don't know how to find them, just check the Wikipedia page, because I don't want to spend time doing that, because, you know, I want to make it clear and consistent here. So these are the numbers here in the group of permutations, right? And I'm going to remove some code up here. So we'll start from scratch. So basically, we want to apply, it says for element 3 and 5 here. Let's start with 3. So what we want to do is we want to multiply 3, the number 3, with each of the permutations, right, in the group. In this case, 1, 2, 4, 7, 8, 11, la 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 la. We want to multiply these, so we multiply the element with the permutation to see what happens, right? So if we do this like this right now, you see we get very large, let's make that bigger as well. Is it possible? No, it's not possible. I can read it for you. It says 3, 6, 12, 21, 24, 33, 39, 40, 42. So, you know, way too big numbers. Why? Because we're working in Z15. We have to do modulo 15 as well, because, you know, numbers change in modulo. So if we do that, then we get 3, 6, 12, 6, 9, 3, 9, 12. That means when we multiply 3 with each of the numbers here in our permutation group, 1, 2, 4, 7, 8, you know, they're gonna work. All the numbers they're gonna take, you know, the result of doing that is just gonna be one of these numbers here. One of these numbers here. I'm sorry I can't make it bigger for you. Maybe I can. Let's see. Zoom. Oh, we can't zoom. It didn't actually work. Okay, you will have to watch in 4K. All right, so it's the only numbers it can take, right? It orbits around these numbers. To make it even more easy to read, let's do this as a set instead, so we don't get any duplications here. And let's see here. Oh, I forgot one. Okay, cool. So it can only take, you know, we multiply 3 with each of the elements here in the permutation group. It can only take the number 3, 6, 9, and 12. So that is the orbit we have, you know. Our number 3 here orbits around these numbers. They are bound together in the permutations here. So that's an orbit, right? Easy explanation. So let's think about the stabilizer. So basically the stabilizer is when you multiply, in our case, the number 3 with a permutation, and it goes back to 3 in Z15, because we're working in Z15. So once again, if we remove the set here, and we do this, we can see here that multiplying 3 with 1 takes it back to 3. And multiplying 3 here with 11 takes it back to 3. So then we know that the stabilizers are 1 and 11 in this case. All right? Easy, right? You know, we just multiply 3 with a number here, or permutation, and it then goes back to 3 in the frame we're working in. We're working in Z15. It's a stabilizer. Nothing happens. So just to make it more intuitive for you, we've done it once here. Let's do it with 5 instead. So, you know, multiply with 5 all of these numbers in the permutations instead. We're working in Z15, so modulo 15. Then it takes the number 5, 10, 5, 5, 10, 10, 5, 10. By that, we know the orbit is 5 and 10. It only goes around 5 and 10. You multiply 5 with anything in this permutation group here, instead of 15, it's only going to take 5 or 10, okay? So that's the orbit. So with the stabilizers here, it's the same. We can just look at this right here. We see that when we multiply with 1, it goes back to 5. Multiply with 4, goes back to 5. Multiply with 7, goes back to 5. Multiply with 13, goes back to 5. So in this case, our stabilizers is 1, 4, 7, and 13. Okay? Because when we multiply 5 with 1, no, not 2. Okay, 1 or 4 or 7 or 13, 5 goes back to 5 instead of 15. So that is our stabilizers. I hope this made much more sense for you, and that it's so much clearer now how it works with the permutations here, with the orbits and the stabilizers. Thinking like this really made it much easier for me. And maybe it is because I'm a closure programmer and I like to do maps, but it's not. You shouldn't be scared of the map. The only thing the map does is applying a function to each and every element here in our list. Okay, so if you're not a programmer, I'm sorry if this scared you away. That was not my intention. But yeah, I really hope that you find it much easier now, because I'm preparing for my exam and I thought this was so much better way to think about it. My math book didn't really tickle my feelings in terms of explanations. So if you like this video, hit the like button so I know that I actually helped you. And if you want to learn more about mostly artificial intelligence and machine learning and technology, but also some random tips and tricks like this, hit the subscribe button and maybe the bell to the right as well, so you get notified, so you don't have to wait forever to find that actual video. And if you have any questions or message of love to me for explaining this for you, just drop them down in the comment section below. And guys, I'll talk to you soon again. Have an absolutely amazing day.